Hi everybody, we are now going to talk about regression and the importance of adding a constant term. And we are going to need pandas for the data structure, the data frame, and we are going to plot our results, and we need stats models to fit our least squares regression model. So we just import these libraries. Of course, we get a future warning, no need to worry about that, but we are going to show why adding a constant is incredibly useful in regression models. So this is a step which you should not forget, because with stats models, we have to add this constant ourselves. So we have to remember to do that. So the mathematics behind it is basically that you have this data structure, the data matrix X, with with observations on the rows, and you have this coefficient matrix beta, which is a vector. So this is just a column vector, and when you take the X or the data vector times the data matrix times the coefficient vector, then you get the estimate of the y variable. But if you do not have a constant, then if one observation in the data matrix, one row in the data matrix, is set to 0, then no matter what the coefficients are, the product is equal to 0. So for all the x's equal to 0, then you would get an estimate of the y variable equal to 0. But this is best explained with an example. So here we have the relationship between price and demand. We have some prices, and we have some corresponding observed demands. And we are going to put this in a data frame called df. And from this data frame, we pick the price and we pick the demand, and we put these into vectors. So we have a y vector with the demands, we have an x vector with the prices, and now we can plot these to look at the relationship. And we are going to use the subplots method, and we just make a scatter plot of x and y, and we want the markers to be square and the colors of the markers to be green. We set an x label and a y label, and we want to set the limits here because we want to show the origin, where y is 0 and x is 0. If we do this, we see that we have the origin with us here, but the relationship between price and demand looks like it's negative, right? So for a high price, you have low demand. For a low price, you have high demand. But here, we want to force the regression to go through the origin, because as you saw up here, if you do not have a constant term, then for any x, in this case price, then y would be forced to be 0, which is demand. So for our regression, we are going to force it to go through this this origin if we do not have a constant term in the regression. So with a constant term, we would expect the regression line to be downward sloping, but we are going to see that no need to worry about the value warning. We just do not have enough observations for all the normality tests. And here we are using, or we are defining our model as y equals to x. These are now vectors of the demand and the price, no constant term, and we want to fit this by the ordinary least squares method. So we are getting one line, and we are fitting this by minimizing the square residuals, and we are printing the summary of the regression result. And here we see that the coefficient we get is just the slope of the price. We do not have a constant term, which means that with our data, we have a positive slope on the price, which means that if we increase price by 1 unit or change the price by 1 unit, we should expect to see a corresponding change in the demand by 0.41 on the positive side, which means that if we increase price, we should see that, or we estimate that the demand will also increase, which is not what we saw in the plot here. We saw that it should have a negative relationship, but what we can do is we can add on a column in our data frame called prediction, and these are gotten from the regression results, the predict method, and we are passing in our x's, which are the prices. So we are now using our model to predict the demand for these specific prices. And we see that, well, the observed demand is high when the price is low and low when the price is high, but our prediction from the model without a constant term is positively related to the price, which comes from the positive slope. And if we want to plot our data, our data points plus our predicted demand based on our model, then we can just make this figure. We just define the figure size here, and we want to plot several things in one figure, which means that we have a scatter plot for the actual values. So we have the price on the x-axis and the demand on the y-axis. These are the observed values. So we label that actual y. We have a marker which is square and the color is green, like previous. And we have also the predicted values. So here we have a plot, and we plot price on the x-axis, and we have the predicted y values, the predicted demand on the y-axis, and we label this the predicted y. And the line should be black, but we want to add some markers on the data points corresponding to the observed prices, and these will then give us the predicted demand for those specific prices. And we want the marker to be round and the color of the marker to be red. And then we want to have some labels on the x-axis and the y-axis, and we set the limits such that we include the origin on the y and the x-axis. So then we just run this, and we see that, well, instead of this downward sloping line, we actually have this upward sloping line which goes through the origin. And you see that our predicted demands for specific prices, they are vastly different from the actual demand which is observed in the market. So this is why you should include the constant term in your regression.